Hi, everybody, and welcome for joining us today. Thank you for being here. Always a pleasure to hear about you. How's everybody going? How's everything doing? Like to learn
Hi,
more?
everybody, and welcome for joining us today. Thank
Oh, hi, Christopher. How are you? Yeah, could you just let me know how's my audio working? Give me an idea if everything is working okay. Hi, everybody. Just give it like 3 more minutes before we actually begin. Thank you, Simon. Appreciate it. Hi, everybody. Where are you located? I always like to know where you're at. I'm located in South Florida, and right now there's a really bad storm going on. It's really bad. It was kind of cloudy to almost all day today. Here it's almost 2 o'clock in the afternoon, and it had been quite cloudy, but a storm just came in and yes, is really hitting out hard. Impressive. What's funny is that I think I saw the guy. I think I heard the guy next door. Not even half an hour ago, had started mowing the lawn. So I guess he had to make a run for it. Excellent. Oh wow, we got from Long Beach, California. Nice. That's cool. Excellent. Okay, let me just gotta kill my notifications. I'm getting these notifications here that I don't want them to be showing up. So let me just get these notifications out of the way. That way there are not. Okay. Oh yes. Good. Okay. Excellent. Takes care of that. Okay, so yeah, hi Simon. I'm almost sure you've participated on some of our other presentations in the past. Is that about right? So California, Morocco. I have not had the opportunity to go to Morocco yet. That would be really nice to go there someday. And oh wow, from Egypt. Thank you, Mustafa, so much for being here. I don't have enough words to express my appreciation. I know the time difference is incredible, so it's a really big sacrifice for you to go ahead and be joining us today. So I just want to thank you for that. Thank you for being here. Appreciate it. Let's see. So I don't know if I actually mentioned it, but I'm actually in South Florida, so I'm like half an hour just north of Miami, but I'm a bit not so close to the coast. So I'm like, I would dare say like 20 miles west from the east coast of Florida. So my name is Edwin Robledo. Almost everybody knows me as Ed, and I'm part of the Autodesk EAGLE support and tech marketing team. And also, I'm actually part of the tech marketing and support team for Fusion 360. Now that it does, and the capabilities of electronic design have been added to it. So Jorge and I actually take care of that support. Jorge, myself, and Rick and testing and things like that. So we're part of that team, working on many levels of it. So, so we're 1 minute in. I'm gonna give it one more minute because I see the class is kind of. I mean, the people logging in is growing quite a bit. So I'm just letting it go. I'll just go ahead and enable my camera. That way you could just take a look at what I look like. Hang on. Let me make sure I have some sort of a background on it because uh, let's take a look and make sure I have a background going on here. Yeah, I do. So, hi, everybody. Thank you for being here. Greatly appreciate it. So, we're going to go ahead and begin our demonstration. So, first of all, I'll let you know that on the Fusion 360 YouTube channel, every day there's been different topics being hosted about Fusion 360. Jorge and myself and Richard, as I mentioned, from Germany, we're doing on Wednesdays. We're always doing some sort of a webinar on Wednesdays. The last topic was mastering the design manager, the filters, as well as the inspector. How do you leverage that in the library? How do you leverage that on your schematic? How do you leverage that on the circuit board? How you take advantage of those panels, those information panels that are there, which a lot of times you might close them because they take away from your drawing time, but they're extremely useful. So we covered that yesterday over at the Fusion 360 YouTube channel. And next week I will be doing a getting started with Fusion 360 electronics presentation as well. So if any of you are interested, we'll be doing that next week. But we have Wayne and Devin, Jason Lichman. I've had the opportunity to attend some of them by Jason and Wayne and Brad. They have been amazing presentations about Fusion 360. The way they break it down is pretty cool. And remember that the trial versions for Fusion 360, if you're interested in using it, have been extended to May 31st. So you could actually apply and get that free entitlement into, which is kind of like a startup entitlement, all the way to May 31st. Usually it's only 30 days. Well, that's kind of equivalent right now because we're at the end of the month. But you always could download Fusion 360, and I'll be using it today a little bit. That way you could understand how the electromechanical capabilities between Eagle and Fusion 360 actually work. So I'll go ahead and turn off my camera. That's enough of that. Okay. So um, when creating consumer products, any type of product that you need that requires it to be inside of a enclosure will require, when it comes to the hardware, will require multiple disciplines of engineering, primarily the circuit board, which is the electronic engineer, as well as the enclosure itself, which is usually handled by a mechanical engineer. Now, ever since we've been part of Autodesk and working with Fusion, I have learned of so many electronic engineers that are very, very capable of doing the mechanical aspects as well. It's pretty impressive. I had not dabbed into mechanical engineering, not much, only a little bit, but now with Fusion 360, it makes it so much easier to do it. So today, what I'm going to be explaining is like, how can you capture an enclosure and bring that into your Eagle circuit board design area? How do you import that into Eagle without any file conversions? As many of you already know, Fusion 3 between Fusion 360 and Eagle, there's no necessity of having file conversion. Conventional or traditional systems require you to either be um, having to convert a DXF file, IGES file, a step file. That way, you could have some level of communication between the mechanical engineer and the electronic engineer. That always needed to exist. So you had to be constantly be converting. So the communication between the electronics and mechanical always had to be some sort of an email. Usually, it's emails or phone calls, just to make sure that the enclosure is up to par with the circuit board. And if there's any modification, let's say I need to move an RJ45 connector or a USB, the USB needs to be moved to the left a little bit. That will take maybe one or two emails. That way I get the right measurement and be able to create another file output in which the mechanical. So with Fusion 360 and Eagle, that's no longer necessary. That's something from the past. At this moment, it's a Fusion 360 includes a free entitlement of Eagle. So it's not possible to actually acquire Eagle on itself. So you get a subscription of Fusion 360 and it will automatically, any commercial entitlement that you purchase for Fusion 360 will come with a free entitlement of Eagle. Just to let you know. I said that question was there on the chat, so I just want to take care of that question real quick. Now let's go ahead and begin our example now. So I have this design made with Eagle. Let me just double. Where did it go? Double click. Okay. See if I can make this work this time. Okay. As you know, this is our start page in Fusion, and I'm sorry, in Eagle. And what I did is I opened up a board and a schematic that I currently already have open. As you all, many of you already know, if you have already used Eagle, and I have a feeling if you're here, there's a small chance if you use part of Eagle already. But the control panel has a browser in which you could see all the different editors and aspects of Eagle as well, including the libraries and your projects, the way you organize your projects. So today I'm going to be working on this board that I had done a little bit of work earlier for a demonstration. I'll be opening up this one up. Let me bring it up. And what I want to do is I will actually want to put this board out. I want to put this board inside of an outline, which is it's going to be captured from an enclosure in Fusion 360. So let's go over the Fusion 360 and learn how those steps work. Okay. Okay, this is Fusion 360, as you can see. This is I'm in the design editor, as you can see right here. I'm in the design workspace. There's multiple workspaces here. I'm in the design workspace, and I just had somebody I think made this enclosure. It's just a regular Raspberry Pi, and since we have these capabilities, I'm just gonna kind of take advantage of it to design my own circuit board inside of this, since it's an existing enclosure. So how would you do that? First of all, I'm going to go ahead and hide a couple of faces here. That way I could get exposure to the bottom. So as you could see, if I click the faces, it highlights which one it is. So I could actually turn that one off. So I'll turn this one off here. And on the rear one that we have over here, I'll turn this one off as well. I'm not deleting it. I'm just turning it off. That way I could just get exposure to the center of it here. Jorge, are you there?
Yep, I'm here, Ed.
Oh, okay. I heard some breathing. I was like, "Oh, what's going on here?" I
Yeah,
thought it was
yeah.
the echo or something like that from YouTube. Hey, hi, Jorge. Nice for being here, man. Appreciate it. How are you? How's it going on your end?
Doing pretty good. I'm sorry I couldn't get in earlier. Started
That's
getting a
okay.
leak in the house over here.
Oh, so yeah, you're seeing the effects of the storm that just came through, huh?
Yes, yes, I am.
Wow, incredible. Okay. So what I'm going to do is I'm going to go ahead and capture this enclosure here. I'm not going to draw it. I'm actually just going to capture it and bring this into Eagle. That way I could lay out my circuit board based on this enclosure that I'm about to capture. So the first thing I need to do is the circuit board is going to be sitting on these standoffs. Okay, it's actually going to be sitting up on these standoffs right here. So for it to be able to do it, since it's not working on one of the planes, these are the natural planes of Fusion 360. These origins that you see here, these are the natural planes of it. I don't want to do it in any of these planes. I actually want to have it on top of the standoff. So to start this process, what we're going to do is that we're going to click on the sketch. So we're going to create a sketch. And before, the first thing is that it asks you when you create a sketch is on which plane you want to do it. You'll notice that the default planes actually highlight, but I don't want to use any of those planes. I actually want to put it on this plane right here, right top of the standoff. That's where I want where I wanted to put my. Eventually, I want to put my sketch at my circuit board. Okay. Now that I've highlighted what plane I want to use, which is on top of the standoff, now what I need to do is I need to project the bottom of the circuit board. I want to project the bottom of the circuit board. I'm sorry. I want to project the bottom of this enclosure because this is more or less the same size that my circuit board needs to be. Okay. I'll make some small modifications to it as we go along. Now, to be able to capture this bottom of the enclosure, I'm going to be using one of the features. I'm still in the sketch mode. As you could see, when you're in the sketch mode, the menus actually change and I get the sketch palette over here, all these options I have over here. What I'm going to do is under the create down right here where it says create, it says project, and I'm going to select the project option. So project include, I'm going to select the project option. Now, whatever I project is going to be projected on that plane that I already defined. Okay. Remember, I created that plane on top of this here. So whatever I project, as you could see, as I hover above the different profiles on this on this pie enclosure, you see that it's not hitting the bottom. It's actually on that plane, and you see it's identified by those red lines. So I'm going to just go ahead and click on this enclosure right here on the bottom of this enclosure. I'll select that. And there's some information here that I do not need, okay, that got projected. So let's take a look here. Okay, so we have, you see these circles here, these holes that they got projected over. I don't need those on my circuit board because it's not going to really, it doesn't really affect my board. So they did not come through. Now here for my standoffs, I only need the hole for the screw hole to be projected, not the outline. So I'm going to select those and kind of delete them. Everything goes right. I'll delete those. I'll delete that one as well. I left click it and I hit delete. Hopefully it's deleting. I'll delete this one as well. Get rid of that one. I'm just highlighting them and hitting delete. As you could see, and okay. So there we go. Okay, there we go. I think I missed that one, and they're gone now. Okay, now what I want to do is I want to actually project the drill holes for each one. So I'm going to click on create and project it again. And remember, there's many ways of doing this. I'm just using the most elementary way of doing it because as an electrical engineer, my mechanical aspects are not very strong. So I'm just trying to show you the most elemental. Now, there's other ways of doing this, which I'm pretty sure I'm a lot more efficient. But this way actually works, and it works really well. I've been able to do it a couple times, and it works really well. So now what I'm doing is I'm projecting those holes right there, as you can see, projecting only the holes now. Okay. Okay, so that gives me those holes that I want. Now, as you could see, the red line is going all the way. I'm going to go ahead and click OK because I no longer have to continue to project. As soon as I highlighted project, this project option actually came up. I already projected everything I needed to project. I'll go ahead and click OK, but I'm still in the sketch mode, okay? I'm still in the sketch mode. Now, the next thing I want to do is that the circuit board is actually going to go all the way to the edge of the board. I don't need it to go all the way to the edge of the board. I need to leave some space. That way it actually will fit into this outline, into this enclosure. So right here, we have this option that says offset. I'll select here offset, and I'll click on one of the sides that I already have. Let me zoom out a little bit. That way you see the effect that it does. I'll click here, and now I get an offset. In this case, when I did the offset, it went into the positive direction. So it expanded what I've drawn 1 millimeter all over the entire profile. I actually want to bring it in negative 0.5 millimeters because I just needed to be a bit smaller than the board outline. So you see the red lines here? It's actually showing the profile that is actually going to be used if I give it a value of 0.5 millimeters. That's correct. And here's my offset menu, and you see the offset right there. The values are the same. I'll go ahead and click OK because that's actually the value I want to use. Okay. Now that I've created the profile and has the holes that I want, I'm going to go ahead and select Finish Sketch. I'm finished. I'm done here. So now I've defined a profile. By default, the sketch it's not deleted. It's just hidden. So I'll go to the browser and I'll enable the sketch option there. That way I could actually see the profile for the sketch. Now here's the steps that I had. I did this demo yesterday, and some people had, I guess maybe I was going too fast. So let me make sure I go very detailed. That way you see exactly what's going to happen now, okay? I'm going to click on Create, and I'm going to select here where it says Create 3D PCB, okay? I'm going to select 3D PCB. Now I'm going to go ahead and select the profile that I actually want to select. As you could see here, get the dialog box. I could flip it, and I could select more than one profile. So this was a complex enclosure in which had some sort of a geometry that it needed me to select define different profiles. I could do that. In this case, I only have one profile, which is this profile right here, for sake of example. Okay. So as you could see, the profile that got generated was the one that we offset. Let's see how that different looks like. Let's take a look here. Zoom in on this. So as you could see here, the profile, we have the original projection that we did. It's right here. That's the original projection that we did. And this is the offset projection. This is the one that we offset. Okay, so we took this projected and we offset, and I want to go with this one. Okay, that gives me a little bit of space. That way, when I insert the circuit board, but it doesn't put it too far away. So when I put in my micro USBs and all my connectors, my audio connectors, and my RJ45s, it's not that bad. It's close enough for me that I could kind of, when I solder them, I could, they will be soldered close enough that way I could plug into it. Okay. So, and you'll see that the holes here get projected. I got my 4 holes from on my standoff. So I'm going to go ahead and click OK. Now, when I click OK, what's going to happen is that it's going to automatically open up a brand new tab and put me in the 3D PCB editor. Okay. So that's what you're going to see. If you notice, I only have one tab open right now. I only have one tab right here, the Raspberry Pi enclosure. Now, as soon as I click OK, look what happens. You see, it brought this into the 3D PCB editor. You'll notice that it opened up a second tab. We had one tab. Now we have the second tab with the 3D PCB editor only. So in a few minutes, you'll be noticing why it does this. And it actually is pretty neat. The 3D PCB editor is it's actually quite powerful. There's a lot of things we could do here, but not right now. It looks like the outline of my board. So as you could see, I was able to, project all the holes and details from the projection. Actually, pretty neat. The fact that it actually even captured that little corner right there from the enclosure. It actually adopted those corners. This would be something that would actually could be done in Eagle directly, but if I don't have to do it in Eagle and I could get it straight from the enclosure, there's no more guesswork that if it's going to fit in here or not. So the first thing, as you can see, it has the name on title and it's dirty. And I mean, when I mean dirty, it's just the fact that it just has an asterisk, meaning that it needs to be saved. All that means, as you can see right here. So let's go ahead and save this so far. I'll click on save and we'll call it Pi 3D PCB. Okay, very well. Now I want to capture this and bring it into Eagle. And let's see how we do that. So let's go back to Eagle. And now that we're in Eagle, we're going to go ahead and, as you know, when you're working in Eagle and you're working from your circuit board, this is the little circuit board that I laid out for this example today, and you push over to board, you notice all the components show up on the left-hand side and you get this default board outline. Now what I want to do is I want to take that outline that I did in Fusion 360 and bring it in here. So I'll go ahead and click on Fusion 360 on the flyway menu that we have here. Now this is going to take a look. First of all, the condition for this to work is that you need to be online. So let me go to the control panel. That way you could understand that. That's actually why I was at the control panel. You need to be online. So you're going to be seeing the symbol right there. You need to be online. Okay. If you're not online, this is not going to work because it needs to be able to access Fusion. And the only way it does that is through the internet. So let me go back to the board. So I'll click on the flyway menu that says Fusion 360. And I have the option either I could create a brand new Fusion 360 design. In other words, this option, what it does is that it actually lets me push my circuit board straight to Fusion 360. Okay, so in that type of scenario, usually the board layout will be driving the enclosure. In other words, I'm not taking into consideration an enclosure if I use this option, create a brand new one. I'm actually just pushing the circuit board over to Fusion 360, and then the mechanical engineer in Fusion 360 will create an enclosure, or you will be creating an enclosure surrounding that. But I'm trying to use an example that is the most common one, which is capturing from an enclosure. So I'll click on link to an existing Fusion 360 design. Now it's going to actually take a look at all the different hubs that I'm a member of. And so I'm going to use the one that I've been using, my personal one, which is Edwin Robledo. That's my hub that the one that I've been doing this experiment with. I'm sorry, this example, but this data set is there. And it was saying loading here as it kind of browse all the projects that I have open. So I need to go to tutorial. That's where I stored it. That's my project folder. So let's go to tutorial, as you can see here. And underneath tutorial, I have a subfolder called April 30th. Okay. And there's my 3D. And now before I actually select it, let me show you how this looks like in Fusion 360 before we actually find it. I want you to have an understanding. So let me expand the data panel as we have here. So here's my tutorial folder, as you see here. This is my project folder. And then under my project folder, I have a subfolder called April 30th. So that's where I'm capturing this outline. And this is the name that I actually gave the project, Pi 3D PCB. And you'll see that that matches an eagle. Pi 3D PCB. Okay. Now let's go ahead and click OK. This is just going to take maybe a minute, hopefully less. And now I have the option to push to Fusion or pull from Fusion. When in doubt, always pull from Fusion. I learned that from Jorge. So when in doubt, always pull from Fusion. Is that right? I think I got that right, Jorge? As you could see, my outline automatically came in. Okay, I did not have to do absolutely no file conversions at all. It automatically came in. So I'm going to go ahead and click on close. I'm not going to push back the Fusion because I actually want to kind of move all my parts into here. Now I have to take into consideration these holes, which are the mounting holes. So let me go ahead and click on close. And I'm going to go ahead and just capture this that I have here. I'm just defining a group, okay? So in Eagle, the group command is always on by default, okay? I could either select single components by just clicking and holding at the origin of the component. Let me find the origin of this part here. I could click on hold. I could click on hold a part. The group command is always active, or I could just click on any blank area and just click and drag and select all the assets that I want, okay? So now I'll just click and hold on one of the origins of one of the components and kind of drag it into here. Wanted to show you this because I don't have to do any clicks. I don't really need to select any icons. It's just already there. So I just take a little guess here and just put it here. Okay. And I'll say what I've accomplished so far. I'll click on OK. And it's always good practice that before you actually start any routing, it's always a really good idea to go ahead and push it to Fusion 360, yes, to make sure that this is going to fit, that we're okay. Notice that my origin is actually the bottom left corner here is my 0, 0. The reason why we usually try to capture in Fusion, this being my origin, is that way when I generate my fabrication files, everything will be in a positive coordinate. So when you submit your Gerber files and your drill files, it's undesirable to have values with negative values, I should say. Okay. Now that I've accomplished this, let's go ahead and save what we've done so far, and let's push over the Fusion 360 to see what happens. So I'll click here, and I want to push to Fusion 360. Remember, my source is still the 3D PCB that I had, okay? If I wanted to push it to somewhere else, I could click cancel link, but I actually want to continue working with that other one that I had. So I'm going to go ahead and push to Fusion 360. The little check marks that you see there, those green check marks that you see next to the name of each of the component, it's just letting me know that those actually have 3D models mapped, okay? The ones that do not have the check mark, it just means there is no 3D model mapped. So let's go ahead and click on push. And this is just going to take like a minute. In the meantime, if there's any questions or anything like that, Jorge, let me know. So what's going on is it's sending everything over the Fusion 360.
So far,
Now-
everything good, Ed.
Now, the libraries that I use for this design were managed libraries. And when you have managed libraries, you have the ability of assigning it 3D models. I'll explain that in a minute, a little later and in a few minutes, but that's why I have 3D models. But you can actually assign 3D models directly from the schematic on the board. I'll show you that as well. So it already completed. Now here's the part that is a little bit confusing. Now let's go over the Fusion 360. I have a confirmation because it's actually letting me know, hey, you know what? There's some data, there's some changes here. I need to refresh. You notice that the components do not show up on the circuit board, okay? So the first thing you need to do is you need to click on refresh, and you actually need to close this. And we're working on this, okay? Actually need to close this tab, and I will double click that project. Now, when it loads again, you'll notice that it loads a 3D PCB with all of the components populated on the circuit board, as you could see here. Okay, so here's everything that we need. Okay. I almost have everything populated here. Not sure why this component did not come up. Pretty sure we had that there, but so as you could see, if on the 3D PCB, if I actually wanted to move something here, I could actually move this part. Look, I used to notice that this resistor is kind of hanging in the air here. Let me just go ahead and move that. So I'll click here where it says move, modify over here in this tab here, it says modify. I could actually select a component. Click cancel. Let's try this one more time. There we go. Now it lets me select the part. Put this guy over here and click OK. Now that I've moved that part, I've moved that component because it actually was outside of the board. I'm going to go ahead and save what I've done. Now it's a really good time to go to put some, every time you save, to put some information here. So you're going to put in a moved R6 into board. I'll go ahead and click OK, save. Now let's go ahead and return the Fusion 360. I'm sorry, the Eagle, and let's see what's going on Eagle over here. So in Eagle, I'm going to go ahead after a while, after several minutes, if I'm working on here, you'll see that this actually turns kind of a red color. But for sake of time, I'm just going to go ahead and kind of force it. So I'll click on Fusion 360. And when it refreshes, it lets me know, look, I'm out of sync. So usually once it catches up, you'll see it like this. Once you're working with Fusion, with Eagle, I'm sorry, if the mechanical engineer in that in the 3D PCB made a modification, eventually you'll see it come up in red like this. You have to make sure you got to be online, okay? So I'll click here. There's a modification, and the modification was this right here. This component, this resistor right here. I guess it was R39, but the 39 was hanging, so I saw 6. So let me click on pull from Fusion. You remember that I did and then I'll click here on pull. And click on close. And you notice that now that R39 has actually moved and adopted that movement that we did over in Fusion. Okay, so let's say what we've accomplished so far. Now, when we're adding components to our schematic, it's preferred that we always add, if you're going to need an electromechanical workflow, it's preferred to be using managed libraries that already have 3D models assigned to them. Eagle comes with a large repository of libraries. I think it's something like 3 to 350 libraries or more, and more are constantly being added. Not all of them have 3D models, so we're trying our best to catch up with that. So when you're doing the add command in your board layout, I'm sorry, on the schematic editor, you shouldn't be adding parts on the board layout unless it's something that is non-electrical. you'll be able to expand some of these libraries. Let me just go ahead and select. You see the managed folders. The ones that have managed folders called Eagle PCB are the ones created by our team. And we have a system by which we could share manage libraries by managed folders. And that's where this one is, because I was actually working with a team. So that's why you see those there. So let's go ahead and select any of these libraries. I'll go down to the RCL library. And you notice the ones that have these symbols here, that means that those have a 3D model assigned to them, okay? That's what that means. So those that have that little symbol next to it, those are pretty neat to use. And we have a really nice repository of those that already have 3D models. Now, you could go to the Open Library Manager. The first thing it's going to let you know is these are all the libraries that you use in your current design. These are all the libraries that you currently have in use. Okay. So every time you do the add command on your schematic or on your circuit board, these are the libraries that are going to be showing up. And unavailable are additional resources, additional libraries that we have available. When it has this little symbol next to them, it's just letting you know that you have not downloaded this library. It's available for download. The other ones that don't have that little symbol, it's just letting you know that they're local, that you have them cached right now. They're not in use, but you have them cached. Okay. So let's go ahead and take a look at some of these libraries and do some covering. So this is from a managed folder that we use. I think Jorge made this team one, or somebody did. So we're members of that one. And these are libraries that are in that shared through that managed folder. Then I'll go ahead and view some more. These are some of my own personal managed libraries. Remember, managed library is that way I can assign 3D models to it. Okay, this is by our team, our librarians as well, the Fusion 360. These are contributed by PCB Layout. PCB Layout also does a really good job at assigning 3D models to their components. We have Seed Studio, we have SparkFun, we have Adafruit, and we have a really long, very long list of available components by Worth Electronics as well. Okay. And the majority of all the Worth libraries, I would dare to say all of them, include the 3D models as well. And we're getting more distributors and manufacturers to add more to this repository, okay? Now, let's say, for example, you're working on a circuit board, and you know what? Maybe it's a legacy Eagle file, or it just doesn't have a 3D model assigned to the component. Well, there are a couple of methods that you could use to actually assign 3D models to your components directly from the schematic or from the circuit board. Let me just select one of these examples here. I'll just select something kind of small because we don't want to spend too much time doing it. So what you do is that you go directly to the component and go to the origin of the part. You could right click the component. And right here, there's going to be the option that says add custom 3D package. Okay. Add custom 3D package. Let me see if it's asking me which managed folder that I wish to work with this component from. I just want to work from my own folder, my personal folder, which is my name. And I'll go ahead and click OK. Now this is online now. Okay. So this is online. We're currently online right now. This package editor is what we call here the package editor. Now I have three options here to assign this a 3D model. Okay. It's a shame that I don't have a step file for this right now available, but there's three options that you could use to assign this a 3D model. First of all, if you have a step file for this footprint, you could just click on upload. And if you've downloaded the step file for it, you could just click on upload, look for that step file. I actually have a repository of step files here somewhere that I keep here. Scripts, step files by name. Step files. I keep a nice repository of step files that I actually download, continuously downloading from my components. So that's one way I could map it. This is mapping it directly from the schematic. Or if this was an IPC compliant type style component, I could use the IPC compliant package generator, which has many templates available to you that I actually would be able to select one of these templates. If it conforms, of course, I could select one of these templates, put in the measurements for that component and click on update preview. That way I could see if it fits. If not, I could select another template and continue until I get the right 3D model assigned to this. Or you could also click on the add option that we have here as well. Let me get rid of that one. And this will let you browse as I've continued to work with many projects. It captures any 3D models that I've been using in the past, any step files that I've been using, any package that I have generated using generator, and it will build a repository of assets, 3D models that I have constantly be using, as you could see here. Now, we publicly have many of them available to you as well. And these are where it says here, public models. So these are contributions by our librarians. So they've been adding many 3D models for you as well. So you could actually select one of these that could map out with that component. And it does have a search option that you see here. So let's say we were to select Pixie. This was a Pixie or something like that. And it would, didn't find any for those. So let's type okay, so there you got some tools, 6 resistors, capacitors, and LEDs, and so forth. Okay, so that's one way you would be able to map them. If you haven't done it in the library, you could do it directly on the schematic. Now let's go ahead and return to the circuit board. Okay, and I'm just going to use the auto router really quick here. I see I have kind of a violation going on here on this component right here. So let me just go ahead and move this over. Let's move this over. That way I don't have, oops, it's moving the whole board. Let me do file undo. Undo. Okay, I'm just going to hit escape because apparently I had a group defined and I was remembering it. So I just move this part over here a little bit, right? I'm not in violation right there. Let me save what I've done so far, and I'm just going to run the auto router really quick. This is the auto router. I'm just going to select medium effort. I'm going to allow it to keep the variant topological router as well as it could select its own grid. Click on continue. It's going to do a total of 10 runs, and we'll pick from one of those. As you know, they all run simultaneously on multiple cores. If you have a computer with multiple cores, it runs in parallel. Sure. I see a question here, there, Jorge, in regards of creating documentation using the application. Absolutely, you can. Yeah, you can. That's no problem. Now we could actually take a look as on the progress of the auto router, as we could see here. We just go along and see what the progress is of the auto router, and we could actually select one of them. The topological router still thinking about it, so let's give it another minute to see if it does anything. If not, we'll just go ahead and select one of these that have 100%. I usually, a lot of times, I'll base my decision on the one that has the least, that's 100%, and with the least amount of VS is what I try to select. And that's actually why the topological router a lot of times takes a little longer. It will commonly be the one that has the least amount of traces, as you could see, and it does a really good job. I really like the patterns that it does, the topological router. So if you're just a little bit of patient, and depending of how dense this board is, it will actually does a really good job at routing the board. That's a pretty good one. So it's a 97%. So I'll just let it finish. Okay. Just give it one more minute. So, Abe, I think I answered your question already. Okay, you're good. So Christopher, you do have a question in regards of how to create a PCB design. Yeah, I mean, you're more than welcome. I'll be honest with you, on the YouTube channel, on our Autodesk Eagle or on the Fusion 360, if you take a look at the at the electronic side of Fusion 360 YouTube channel, we've covered many projects of how to put together a circuit board. But if you want to contact us, I always put our email there. And just to let you know, next Wednesday, we are hosting on the Fusion 360 YouTube channel. We're going to go ahead and create a brand new design just from scratch. How do we start? We're just going to grab some parts, put them down on a schematic. How do we connect it? And we're just going to go through A to Z, and all the way from starting on the schematic all the way to creating, exporting your manufacturing file. So you're more than welcome to join us next week. If you write me at support.eagle@autodesk.com, I'll gladly send you a reminder on that one as well. So I'm going to go ahead and select here this completed route that we have here. Click on End Job because I'm just going to actually happy with those results. I'll click on Save, and let's go ahead, and you see that it's in green. It's just letting me know that I need to push back to Fusion 360. That way it could catch up. So let's go ahead and push this back to Fusion 360. We'll click on Push. Hey, Fox, you're never too late, Fox. You know, Fox, one of these days, I want you to host this meeting for us one of these days because I like to see it from your perspective. You're one of our experts, so glad you made it. Okay. Now, as it might take just a little bit longer, just because of the fact that I've added so much information to it. So let's go over to Fusion 360. So what's our experience here? As you could see, I need to do a refresh. Now I'll go ahead and close my project. We're hoping to improve on this interface really soon. That way you don't have to be opening and closing. It would be really nice if it automatically showed up. Okay, and as you could see, my routes came over. Any modifications that I have done to the circuit board would have come over as well. Okay, so we have everything that we wanted here. Well, now let's okay, so you have your vias. Now, the thing I really want to point out here is that every aspect of the circuit board is a separate asset. In other words, every via is an independent component. It's actually an asset here. So the via consists of these copper rings with a plated copper ring in the middle. These are all independent extruded components. The traces are extruded components. And what's important of this is that let's say you needed to do a tool path. If you were to CNC this, you actually can because all of the information here is selectable. In other words, in when we were doing this with Fusion 360 and Eagle before, all this information when it came to the traces, everything like that, was being brought in as a picture. It was an image. But now they're actually each one is a individual asset. And because of that, because we've done it this way, since the developing team had the inspiration of actually doing it this way, now if I want to change to the simulation workspace, by assigning watts to my components, I could run the e-cooling properties that we now have in Fusion 360. So I could actually click here. I don't want to do it because it kind of takes a long time to solve it. And I could assign watts, which is going to be the thermal heat capabilities of the component, and assigned by watts. And then I could actually run a thermal simulation on it. So I advise you to actually try this out. There is an update video made by this team that actually added this to Fusion 360 not too long ago. Okay, so now And the last thing I want to do is, let's say I wanted to make some modifications to this board outline. As a mechanical engineer, actually in Fusion 360, it's a lot easier to make changes to the board outline compared to making changes maybe in Eagle. Might be easier. And this one, it's maybe not so relevant, but if you're working on a complex board outline, you may want to make modifications in Fusion other than in Eagle. So let's see how that would actually be done. Okay. So as you notice, there's a timeline here down on the bottom right here. So this timeline is for sketch, and then we have our extrusions and some other on the timeline to complete the entire circuit board. So what I'm going to do is I'm going to right click on the outline of the board. See, it says outline Pi 3D PCB. I'm going to right click it, and I'm going to select edit sketch. Okay, it's going to put it flat there. Now I have all the sketch design tools that are available. For my example, I'm just going to do some minor fillets here. So I'll go here and I'll just round off that corner right there. And I'll just continue doing some rounding corners here. You could see there some minor changes. Okay. And since we're at it, we'll just do them up here as well. Okay. Now we'll go ahead and click on Finish Sketch. It builds everything all over again. As you could see, it builds the browser. And now my board has the new board outline. Now we have to go ahead and let's save what we've done so far. So we'll go here and save. And I'll take Modified Board Outline. Fillets. And click OK. Now that I've done this, let's go back. And now I got a little asterisk, gave me the check mark, letting me know that it's completed. Let's go back to Eagle and see what happens in Eagle. Click Close. Go here. Lets me know that I'm out of sync with Fusion. I got to pull back from Fusion. And you're going to now see these modifications that are going to happening here and each one of our corners, as you see there. They'll be happening in a minute. The reason why I like actually giving a name, every time I do a save, I put a comment. As you can see, it's the same comment I did in Fusion. Modified board outline with the fillet corners, as you see here. The same one that I did when I saved it. That was a comment I put, and I'll click on Pull. So, if you needed to make any type of updates to the board outline, it could be done in Eagle, and then Fusion will catch up. They could be done in Fusion, which is, I think it's better to do it in Fusion because you have all those tools, you have splines, you have everything that is necessary for any type of complex outline as well. Okay, so it caught up. Now let's go ahead and push back to Fusion really quick. That way we have a full synchronization between Fusion and Eagle as well. And please observe that at no point in time did I ever have to file convert. I never had to convert anything to anything. The whole time I've only had to just kind of like do a push and pull every now and then. That's all I needed to do. Okay. So let's go over the Fusion. Fusion will let us know also when it's done. When we actually see the refresh here, it'll let us know when it's finished. Okay, refresh and close. And let's go ahead and open it up. While it opens, as you saw, my corners got rounded off as I did already in the 3D PCB. You got fillet. Okay, so now we're fully synchronized. Now what we want to do is I actually want to put this circuit board inside of this outline, right? We want to put it in here. Okay, so let's go ahead and do that. So what I'm going to do is I'm going to right click here. I'm going to select Insert into Current Design. Now, the orientation of the circuit board is going to be kind of off from the enclosure because the origins that Eagle uses versus the origins that Fusion 360 uses are totally off. Okay. And that's something we're wanting to improve on. Um, as I said earlier, we usually put the circuit boards all that way you have positive coordinates. In Fusion 360, you don't necessarily do that because of symmetry. You may want to start working from the center and go out. It doesn't really matter if you have on negative coordinates at all. Now, so let's go ahead and start moving this around a little bit. Let's line it up. Move that 90 degrees. And let's move this way, over here this way. Move that 180 degrees. Put 180 degrees there. That way it's perfect. Now that I have it in the right orientation, what I'm going to use is I'm just going to use the joint option under assemble, the joint. And I'm going to tell it, I want to, yes, go from this hole that's right there. I actually just want to line it up. I want that board to line up on this surface, on this hole, on this standoff that we have right here. Okay, if everything goes right, it lines it up for me. I'll go ahead and click OK. And now I've actually put the board inside the enclosure. Let me just get my browser box up. Now, you'll notice that when it actually brought it in, it brings it in as a link, as you could see here. It's actually a link. Let me see. You see, the circuit board that I just brought in is linked. Here's the 3D PCB, the Pi 3D PCB. It's linked. So as of right now, I cannot really make any modifications here. Now, if I go back to the 3D PCB or in Eagle, if I go to Eagle, and let's say I just move something. So let's go ahead and move this right here. We just go ahead and move this part right here. Just make a movement. Okay, we'll click OK. And we'll save it. And then I just want to cycle through Eagle again. See, it automatically says that I need a pull. And this is the last part of this demonstration here. This is the last part. And so if you have any questions or anything like that, Jorge's there. We could address them. Okay, now I'll push back to Fusion. That way it catches up. I could have moved these connectors a little closer to the edge of the board. But, today what we really wanted to demonstrate was the electromechanical capabilities. And there's just one more that I want to end this with. That way you could see that if I make the updates in the 3D PCB, I can make it in the Eagle itself or in the 3D PCB. Wherever I have inserted that circuit board in any enclosures that I've inserted it, if it's one or more enclosures, that link will actually let me know that there's some updates. That way I could get the latest revisions and add it to my total design. So, okay, so let's go here. You'll notice that when I save my 3D PCB, I get 3 notifications here. So that one there, and this one over here. If I hover over them, it's just letting me know, look, need to click here. That way I could get the latest updates that are on the 3D PCB for that link specifically. I'll just go ahead and click on OK there. And you'll notice that our IC17 is actually going to move as soon as it completes the synchronization. As you could see, it moved. And since we synchronized between the 3D and PCB and Eagle, it actually moved all the landings as well. Same The same changes I did in the 3D PCB and synchronize between Eagle and Fusion 360. You'll see that everything now comes and it's actually everything is lined up. My holes are lined up, my screw holes are lined up, everything lines up exactly where I want it. So I could continue lining up here. Now, the nice tool that you'll be using here that I always like to recommend is this Inspect. Inspect actually lets you make measurements on this world. Let's say, for example, this is not actually lining up here from this wall to this wall. With a measurement, you could actually get the delta for here. That way, that way you could go over here and make that modification here. Then you could actually move that delta here on that component. Okay, so always make sure that you understand that there's inspect. We have inspect here as well. So if you need to make measurements over here as well, you could actually accomplish that easily right here. You'll get, measurements here. So that way you can align whatever needs aligned between the circuit board version, the circuit board that's inside the enclosure, and the 3D PCB. That concludes today's demonstration. I wanted to do it a little shorter, but I really wanted to go as much detail as possible. My internet has been working really well this today, so I really wanted to go as much detail as I could. I appreciate everybody joining us today. Hopefully, the information that you wanted covered is I was able to cover it. And next week, join me on Wednesday at the Fusion 360 YouTube channel. Jorge and I will be there, and we'll be creating a brand new design for those of you that are interested in adopting maybe using Fusion 360. I'll do a little preview. I have 2 more minutes left here, so let me show a little preview of that really quick. So, for example, I'll just create it right here. So I'll click on in the pull down menu and I'll select electronic design, as you see here. And this brings me into what's called an electronic document. And now from here, I could actually select a schematic that I actually already have done in Eagle. I'll select from my computer. And let me go to my projects, Eagle projects, projects, and we'll select, there we go. We'll select the schematic right there. And in the electronic document is where you actually control what circuit board is linked to which schematic. Okay, so I'll just go back and select the board file. And as you could see, we have a circuit board editor, a fully capable circuit board editor within Fusion 360. And I could actually from here go ahead and create the 3D PCB directly from here as well. So if you wanted to work directly from Fusion 360 and create your circuit boards, it's possible to do it right here in Fusion 360. But the link between Eagle and Fusion 360, it's valid and it works really well as well. Okay. So I just wanted to bring this up really quick. That way you could see if you already have a Fusion 360 license, how you could take advantage of it to take care of your electronic designs as well. Jorge, is there anything that needs to be addressed, you think? Yeah, Martin. So hopefully with this demo, you could see that you can use your Fusion, your Eagle design files in Fusion, but also in Fusion, if you have a design file or you've been supplied a design file or you have one in Fusion, you could always export that as well. And it'll give you the option here what version of Eagle you actually want to use. Most probably you'll be using this one that says Eagle 9.x. That way it keeps a lot of the properties. Or you could select Eagle board file as well if it's kind of if it's an earlier version than version 9 as well. And you could do this for the schematic as well as the board as well. Okay. Oh, thank you for the kind words, Mustafa. I went over just a little bit, but I think I covered everything in detail as possible. I'll make the recording available ASAP on our YouTube channel. So for those of you that would like to review any of this, you'll be able to access it. Just want to say thank you to Jorge for taking care of the chat. I don't have enough words to express my appreciation for taking care of those questions, and for all of you that joining us. Please, I'll be posting some more future webinars for next month for May. So I hope you join us there as well. Okay, everybody, have a great day, and thank you.